Now that we have seen the algorithm behind quicksorting algorithm, let's go and let's write the Python implementation for it. For that, inside this sorting folder, I'm going to create a new file by the name quicksort.py. Okay, let me just close all these files. Now let's write a class called quicksort, and in this let's write the quicksort function. Okay, so the first argument will always be the reference of current object, and it will basically take a list of a group of integer values, and it will take the start index as well as end index. Okay, based on the start index and end index, we will use these values to call the same function recursively on the left part of the array as well as the right part of the array. Anyway, I explained these things in the pseudocode, right? Now, so how many times we will have to call the same function recursively, right? That means as long as there are unsorted values either on the left side of the array or on the right side of the array. So how will we able to differentiate it? So we will be able to differentiate it based on these two, start index and end index. When will we have unsorted values is basically as long as the value of start is always less than the value of end. That means that they haven't overlapped with each other. That means that there are still unsorted values on the left side of the array and right side of the array. So for that, since it is recursion, we will have to write the base condition, right? So if start is greater than or equal to end at any point of time, we will simply return the array that we have got, which basically is sorted, because all the values on the left part as well as right part are exhausted because start has become greater than or equal to end. Okay, if this is not the case, then what we will do, we will try to find the pivot value first. Let's assume that the pivot index is given by a function self dot pivot. This function we haven't written yet, but we will write now, and it will take the array and it will take the start index and end index. Okay, in this array, whatever we have given, we will take a value and we will move that value into its perfect position, so that all the values on the left side of it are smaller than the value at the pivot index, and all the values on the right side are greater than the value at the pivot index. After that, again, to sort the values on the left side, we will have to call the same function, right? So for that, what I will do, I will simply call self.quicksort, and this function will take the array, and start index for the left part is always the start value whatever we have got, and end index is, because we moved the pivot value into its perfect position, pivot index -1 will give us the end bound for the left part of the array. So the left value, end value will be pivot index -1. Okay, once the left part is done, we will have to move on to the right part, right? For that, self dot quicksort of, again we will pass the whole array, and the starting index will be pivot index +1. So for that, pivot index +1, and the last value will be whatever the end index that we have got. Okay, once both the values are both parts are sorted, we will simply return the array. Okay, so this is how we actually implement the quicksorting algorithm. One thing that you have to remember is, in every recursion call also, we are passing the whole array. We are just trying to sort and move the values based on the start index and end index. So quicksorting is also one of the in-place sorting algorithm only, but we are going to use recursion for achieving that. Now, if you see the implementation that we have done here, we haven't implemented the pivot function yet. So let's now implement that pivot function. So def pivot, and the first argument will always be the reference of current object, and it will take the array and it will take the start index and end index. Based on the values that we have from start index till end index, we will take one of the value and we will adjust it into the perfect position for that specific value, and we will return that specific index as part of this pivot function. Now, if you remember the algorithm that I had explained earlier, what we will do, we will assume whatever the value we have at the start index itself has a pivot value. That means that in the beginning we assume that whatever the start value we get itself like a pivot index. So let me define some variables. Pivot index equal to start, and the pivot value will be ARR of start. Okay, whatever the value we have it, this start index is the pivot value. Obviously that means pivot index we are assuming is at start index only. Now our job is to compare all the values from this start plus 1th index till the end index, and we will have to find the perfect position for this pivot value. So for that, what we will do is we will simply run a loop for I in range of start plus 1, because we will need to compare the values from start plus 1 till the end index. Till end plus 1, we need to include end index also, because we are passing the end array indexes here. So we need to run till end plus 1. That means that the loop will run till end. Okay. Now what we will do, we will compare the values of pivot and the value at ith index. So pivot is, if pivot is greater than the value at ith index, then what we will do, we will simply increment the pivot index to next value, which is nothing but pivot index plus 1. Now we found one smaller value that is smaller than pivot, so it has to come on to the right part of the array, right? So what we will do, we will simply update. For that, I'm going to define a temp variable. In this temp variable, let me just take enough spacing here so that it will be visible clearly. Temp variable, I will take the copy of value at ith index. Now whatever the value we have at pivot index should be moved on to the ith index. So ARR of I equal to ARR of pivot index. Now pivot index should get the value of ith index, which is at the variable temp. So what we will simply do, we will simply do ARR of pivot index equal to temp. Okay, now we have swapped the functionality. By implementing this logic, what exactly we are doing is, we are basically moving all the values smaller than the pivot are coming on to the left, and all the values that are larger than pivot are going to the right side. Okay, now if you observe here, this pivot is still not moved to its appropriate position. But once we complete this logic, right, whatever the value we have in this pivot index, that is a perfect value. So what we will do, we will simply swap the values at start index and pivot index. For that, we will simply take another temp variable. Into this temp variable, I am going to take the value of start, and array of start will get the value of pivot index, and pivot index will get the value of temp. Okay, in the end we will simply return the pivot index. Okay, this is how we actually write the pivot function. Now this pivot function is written in the pivot index, right? So based on that pivot index, we are calling the same function on the left part as well as right part. Thus in the end we will get the sorted array. So let's try to call this function and pass on some array some values, and let's see if it is actually able to sort the values in the ascending order like we have discussed. For that, let's say I'm going to create object quicksort qs.quicksort. Let me pass some values like 23 minus 23, 67 minus 40, 12, 4, probably some like minus 10. Okay, let's assume that these are the values we want to pass. Along with that, quicksort will take the values of start and end indexes, right? That is nothing but 0 as well as the last index. So what we will simply do, let's just take it into some variables so that we can pass ARR equal to this. Now let's just pass ARR 0, and the last index will be length of ARR minus 1. Okay, we are passing the indexes. That is something that you should remember. That's why in the pivot implementation also we are running the loop till end plus 1 here. Okay, now let's try calling it. For that we will simply, in the terminal we will simply do python sorting quicksort.py. okay, so I did not take this result into some variables. Sorted underscore array equal to this. Now let's print it. Print sorted array. Okay, now let's just run this. Okay, do you see the values of the array have been arranged in the ascending order fashion? Okay, that is how we actually perform the quick sorting algorithm. The important difference that you have to remember is, in the case of merge sort, we have divided the array into two parts based on the length of the array that we get. We simply divided the array that we get into two equal parts, and based on that we call the same function recursively. But in the case of quicksort, what exactly is happening? Based on the pivot index, we are actually dividing the array into two parts. That means that technically one part of the array can have larger set of values or not, no values at all. This is something that you have to remember. That is a major that is one of the difference here. Okay, I hope things are clear to you and you are also able to implement this. And if you have any doubts, you can still reach out to me. I'll definitely help you out. Okay, thanks for watching. That's it for this quicksort implementation video.